So hey guys, today we're going to discuss the problem. Given an integer n, the task is to count the number of n-length strings consisting of lowercase vowels that can be generated based on the following conditions. The conditions are each a may only be followed by an e. An example for that is ae. ae. Each e may only be followed by an a or an I. So an example for that is ea, ei. Each I may not be followed by another I. So an example for that is IA, IE, IO, IU. That is except II, rest all the combinations of I with all the remaining vowels are considered. Each O may only be followed by an I or a U. Example OU and OI. Each U may only be followed by an A. So example for that is UA. Now let's think of the solution. In case there are no constraints, the answer would be a number of ways to select two letters from 5 unique letters. And based on two conditions, like whether the two letters chosen are same or the two letters chosen are different. Suppose they were same, the possible letters are A, EE, II, OO, UU. There are 5 ways to do that, and 5C1. And if the two letters chosen are different, A, E, AI, AO, AU, EI, EO, EU, IO, IU, OU are the possible strings, and the 10 ways to choose such strings, and that equals 5C2. So the total number of ways is 5C1 plus 5C2, that is 15. But this is wrong since the question puts a constraints like A can be only followed by an E. So whenever there's an ordering, like when there's after A only E can come, when there's such an ordering, think of this topological sort approach where you construct a directed graph based on the constraints. Now how do you construct a directed graph? Each A may only be followed by an E. So an example is AE, but not EA. So you draw a directed edge from the vertex A to E. Similarly for the rest, I'll take an example. Suppose each U may only be followed by an A. So there should be a directed edge from the vertex U to A. From the vertex U to A, there's a directed edge. So this represents that constraint that after U only A can be taken. Like U is followed by an A. So that was a directed graph. This is the directed graph. I'll just pause for around 2 seconds. Yeah. Okay. So it's represented using an adjacency matrix. Now, what's an adjacency matrix? It's just a two-dimensional array or vector. So this is an adjacency matrix for that graph. For this graph. So what is the adjacency matrix? There are five vertices. So suppose there's an edge between two vertices, then it's represented by 1. Suppose here there's an edge between A and E. So if I show it in the graph, there's from A to E there's an edge. There's a directed edge. So it's marked as 1. Suppose there's no edge between two vertices, then it's then nothing is written over there. So suppose there's no edge from A to I. So see, there's no vertex from A to I. It's from I to A, but it's not A to I. If it was A to I, then this would have become 1. But there's no edge from A to I, so it's null. I hope you understand. And that's how the whole adjacency matrix is filled. Similarly for the rest, I guess you can do that, it's not a big deal. Then this is how we represent the adjacency matrix in a code. So there's a vector inside another vector. So each index in this vector will point to the adjacent nodes. So suppose the 0th index of the outer vector will point to another vector 1 1e. So this indirectly means there's an edge between a and e. So similarly, the first index of the vector, outside vector, will point to this inner vector 0, 2. This indirectly means there's an edge between ea and ei. If you want, you can check in the graph. See, there's a from from E to A there's an edge, from E to I there's an edge. So I hope you understand. From E to A there's an edge. See this arrow is the most important thing. From E to I, this arrow is the most important. Yeah, so similarly the rest. Now we initialize a 2D array dp of n plus 1 and 5, where dp of n char denotes the number of directed paths of length n which start at the particular vertex char, or in simple terms, dp n char just represents the number of n length strings which starts with the character char. So I'll take an example better. dp of 2, 3, where n is the length of the string is 2 and character representing the index 3 is vowel o. So what will dp of 2, 3 represents is the number of strings of length 2 and starting with character o. dp of 2, 3 will contain 4. The 4 strings possible are oa, oe, oi, ou. So we initialize dp of 1i as 1 since the string length 1 will consist only one vowel in the string. So that is strings of length 1 which starts with the vowel a is only a is possible. Strings of length 1 starts with the letter e is e. Strings of the length 1 which starts with the letter I is I. Strings of length 1 which start with letter O is O. Strings of length 1 which starts with letter U is U. So that's why we fill dp of 1i is equal to 1, because dp of the length, if the string length is 1, the vowel itself is a string. So this is a dp array. This represents the string length. This represents the vowel which it starts with. So we fill this whole entire row with 1, because since I told you that string length of 1 which starting with the vowel itself. So if it starts with a, there's only one blank to fill, so only a is possible to fill. So similarly e, similarly I, similarly o, similarly u. Now we go to the next line of code. For int I is equal to 1, I is less than n, I plus plus, it traces from 1 to the length of string minus 1. This is the outer loop which it traces from 1 to the length of the string minus 1. So for u is equal to 0, u is less than 5, u plus plus iterates from 0 to 4, where number of vowels is 5, which is 4 minus 0 plus 1. And dp of I plus 1 u is equal to 0 initially. The value as initialize the value as 0, number of strings of length I plus 1 that starts with the character of index u. That is an example. Example is index 0 represents a. So number of strings of length I plus 1 which starts with the letter a is 0 initially. For int v in the relation u, for every value in the graph edge which is represented as a vector. So this is a vector, so this relation u represents a vector. So what is this line of code does is it iterates to each element in this vector. So sorry for that. So suppose this is the relation u. Relation is the vector of vector. So if you're accessing the index 0, it will return this whole vector. Now suppose we are in this for loop, so we will take 0 for the first time, next time it will take 2. So that's how you access this vector using the index u. So that's about it. In 0th index vowel a is represented as 1. It's the vector inside the vector. This is the main part of the code. dp of I plus 1 u plus or equal to dp of I v. So what does this represent is the number of ways to fill I plus 1 length string starting with the character represented by the index u plus or equal to number of ways to fill I length string starting with the character represented by index v. So what this line of code actually does is, suppose this e that is two length strings that starts with a, suppose we want a three length string that starts with b or o. So what we do is we just fill in the value. So what happens is, this is a three letter string that starts with the letter o. So what you do is you just add the add the number of ways to form a. So you just add o in the beginning of the string to form a new string. So this is now is three letter string that starts with o. So it depends on the values of the previous, that is the two letter string that are formed starting with, so say in this example a. There are many other strings also possible. Suppose I take ei. Suppose I take ei, and this is the two letter string that start with e. Now if I want to add find the three letter strings that start with o, I just append o in the starting. So in this form, so you add the number of ways to form ei. Thus you get the result to find the number of ways to find the three letter strings that start with the letter u. That's what this is saying. So I plus 1 is the length of the string here. I is the length of the string here. U is the character that represents. V is the character that previously started. If I take in this example, U is O and V is A. Because we have two letter strings that starts with A, which is this. I is 2 here and V is A here. So if you want to find the number of three letter strings that start with O, this is a possibility where you just append O at the starting. So you increment the length by 1 and you change the variable as O. U is represented by O here. So that's what this is saying. So the number of ways to fill one length strings with vowel 1 is 1, because I already told you that there's only one possibility that the string, when the string length is 1 and there's only one vowel, so to start with, so it can only take the vowel itself. So it'll take A here, it'll take E here because it starts with E. Because it starts with I, it'll take I. Because it starts with O, it'll take O. Because it starts with U, it'll take U. So now we'll go into the next part. Now if you want to find the ways to fill two length strings which starts with A, what we do is we look into the adjacency matrix or the graph. So if you want to fill with A, we look at the income. We look at the edges from A. We look at the edges to A. So that is from E to A. There's an edge. So what we do is number of strings starting with A is 0 plus number of ways to form one letter strings E. Now why we take only E to A is because there's an incoming edge from, there's an outgoing edge from A to E. So from A to E, there's only one outgoing edge from A to E. That's why we take only that edge, and we append number of ways. So number of strings starting with A is equal to is equal to 0 plus number of ways to form one letter string E. Append A to E and to form AE. So 0 plus 1 is equal to one way. So we update this two letter string that starts with A, and the only possibility is AE based on the above constraints. Now if you want to find the ways to fill two length strings that starts with E, so that if it starts with E, then you have to, there's only two possibilities, that is from E to A there's an edge, from E to I there's an edge. So from A, the number of two letter strings starting with E is 0 plus number of ways to form one letter string starting with A. So you append E to A to form EA. Similarly, from I, number of two letter strings starting with E is 0 plus number of ways to form one letter string starting with I. So you append E to I, so EI. Total number of two letter strings starting with E is EA and EI. That is two ways, so you update the DP matrix as 2. So EA and EI is the two strings that are possible. Now if you want to find the ways to fill two length strings starting with I, so we look at the adjacency matrix and we look at the graph. So what we find is, we find there exists four edges from I. So from I to A, I to U, I to O, I to E, there is four edges. So if you consider from A, number of two letter strings starting with I is 0 plus number of ways to form one letter string starting with A. So what you do is you append I to A to form IA. Similarly, from the edge, vertex E, number of two letter strings starting with I is 0 plus number of ways to form one letter string starting with E. So you append I to E to form IE. Similarly, from O, number of two letter strings starting with I is 0 plus number of ways to form one letter string starting with O. So what you do is you append I to O to form IO. And similarly, from U, so number of two letter strings starting with I is 0 plus number of ways to form one letter string U. So what you do is you append I to U to form IU. Okay, so the total number of two letter strings starting with I is IA, IE, IO, IU. So there are four ways to do it, and you update the DP array as 4. So here number of ways to find two letter strings, it starts with A, you have updated to 4. Now if you want to find the number of ways to fill two letter strings that starts with O, so we look at the adjacency matrix and we find that there's an edge from I and U. So there's an outgoing edge from O to I and O to U. So there exists, if you say to I, if you take the directed edge from O to I, number of two letter strings starting with O is number of ways to form one letter string starting with I. So what you do is you append O to I to form OI. Similarly, number of two letter strings that start with O is 0 plus number of ways to form one letter string that starts with U. So append O to U to find OU. So total number of two letter strings starting with O is OU and OI. So there are two ways to do that. So we update the DP array to 2. So here we updated to 2. Okay, so similarly for the two letter strings that start with the character U, is there's only one way based on the constraints, that is the graph. So there's only one way, that is UA. So we update it as UA. So the total number of two letter strings that can be formed based on the constraints are AE, that is 1, that starts with A. There's only one possibility, that which starts with E, and two letter strings are, there are two ways, EA, EI, which starts with IA, IE, IO, IU are the four possibilities, which starts with O, OU, OI are the two possibilities, which starts with U, UA is the only possibility. So totally there are 10 possibilities. So how do you write this in code is, you just
for all the vowels, you just add the nth. This is what we want in the question. We want to find the, one second, I'll take the question again. So what we actually want to find is, we want to find the number of n length strings consisting of lowercase vowels based on some conditions. We want the total number of n length strings that can be found. So the final line of code to summarize, to get the final result, it's given by this line of code, which is, we run a for loop through all the vowels. So from I is equal to 0 to till I is equal to 4. So we for dp of this represents n length strings which starts with the vowel represented by the index I. So suppose 0 is represented as A, so it adds total number. That is what we did here manually. That is, suppose for A there's only 1, so answer plus 0 plus 1. This is what the code does actually. So it runs through all the possibilities and it just adds all the values. And that is the final answer. So you just add the number of ways to form n-length strings that starts with the character represented by the index I. Thank you.